today's lesson is on systems of equations using elimination. This is our third and final lesson. As always, we have a video guide to go along with the video. If you have not already printed the video guide, go ahead and stop the video, print the video guide, and then come back so you can work out the problems with me. So for problem number 1, we have two equations. Our first is negative 8x minus 5y equals 25. And the second is negative 5x minus 4y equals 13. Now remember, elimination means we want to cancel out one set of letters, okay? So if I take a look at my x's, I have a negative 8x and a negative 5x. My letters are the same, but the numbers are different, so these will not easily cancel. So I'm going to go ahead and take a look at the y's. Letters are the same, but my numbers are again different, 5 and 4. So even if the signs were different, which they're not, but if they were, they still wouldn't cancel, okay? Because our numbers are not the same. So this is a little bit more challenging. Our previous two lessons, either we were just able to add them right away, or we just multiplied by negative 1 and then we were able to add them. That's not the case in these problems. What we're going to have to do is something that I like to relate to fractions, which I know most people don't like, but it's similar to finding a common denominator. We are going to try to find a number that 8 and 5 can both become. Something that you could multiply both of them by some number and they could both become that bigger number, okay? And I always work with the biggest number and then kind of go from there. So I deal with 8 and I think, is there anything I can multiply 5 by to make it 8? And the answer is no. So then I go from 8, I go, okay, well 8 times 2 is 16. Can 5 become 16? No. So I go 8, 16, 24. Can 5 become 24? No. 32 would be the next one. 8 times 4 is 32. 5 cannot become 32. But 8 times 5 is 40. And 5 can become 40. So 40 would be my number here that they could both become. I could multiply them both by some number and get them to be 40. But 40 is kind of a big number. So what I'm going to do is take a look at the y's and see if maybe there's a smaller number I could use. All right, so I have 5 and 4. Well, deal with a bigger number. 4 cannot become 5, so let's try finding multiples of 5. 5 times 2 is 10. 4 cannot become 10. 5 times 3 is 15. 4 cannot become 15. 5 times 4 is 20. 4 can become 20. So 40, 20, I would rather use the 20 because it's smaller. So here's what I'm going to do. 20 is my goal. That's what I want both of these to become. So I have to think to myself, what number, when I multiply it by 5, will give me 20? The answer is 4. 4 times 5 would give me 20. So I'm going to multiply this first equation by 4 so that my y term becomes 20. I have to do the same thing at the bottom here. I have to think, what number times 4 will give me 20? Well, that answer would be 5. See how I kind of just flipped them? I took the 4 from the bottom, I multiply it to the top, take the 5 from the top, and I multiply it to the bottom. That'll always work, okay? So if you want a simple way to do it, just take the bottom number, multiply the top by it, take the top number, multiply the bottom by it. Now we must determine if I have to make one of them negative, okay? And the way to do that is to determine, do I need to change the signs? Looking here, my signs are the same. Remember, you want the signs to be different. If they're the same, they don't cancel, they just add up to be a bigger number, all right? But if they're different, they will cancel out. So, because I want the signs to be different, and they're not, I'm going to make only one of these negative. Because now, when I multiply negative 4 times negative 5, I will get a positive 20 for the first equation. When I multiply 5 times negative 4, I will get a negative 20 for the second equation. So, just make one of them negative, and that's going to change the signs here. One of them will be positive, the other one will stay negative, and then they will cancel. So I'm going to multiply this entire equation by negative 4. Negative 4 times negative 8x is 32x. Negative 4 times negative 5y is positive 20y equals negative 4 times positive 25 is negative 100. That's our first equation, okay? Second equation, multiply it by 5. 5 times negative 5 is negative 25x. 5 times negative 4y is negative 20y. And look, same letter, same number, different signs. Perfect. They're going to cancel. And then that equals 5 times 13 is 65. From here, I can add the equations now because something is going to cancel. So if I add these together, 32x and negative 25x, the signs are different, so I will subtract those. 32 minus 25 is 7x. The 20y's cancel out, those are gone. Equals negative 100 and positive 65. The signs are different, so I will have to subtract. And if you need to, go ahead and borrow. Borrow from this 10, make it 9. 10 minus 5 is 5. 9 minus 6 is 3. And keep the sign of the bigger number. So it's negative 35. And then I just divide both sides by 7. So x equals negative 5. Whew, that's half my answer, all right? But one point I do want to make is that it was this first couple steps that were different. This part is the same, and our next part, when we find y, it's exactly the same as what we've learned before. So this first part is going to be challenging, okay? That's because that's the part that's different. The rest of it should be very familiar to you now. We've done this this is our third lesson on it, okay? So the only part that's different is that first part. Now, to determine which one you should use to plug in negative 5, you can use actually any of the 4. However, I will point something out. The 2 that you used, like when you multiplied, will always have bigger numbers because you've multiplied them both, this one by 4, this one by 5. So you can tell our numbers got pretty big. So I personally always use one of the original equations because they will always have smaller numbers, and I like to work with smaller numbers. So I'm going to use the second one because the numbers are the smallest. So I'm going to have negative 5 first, but instead of x, I'm plugging in negative 5. And remember, I plug it in for x because that's what it's equal to. So I put negative 5 in for x. The minus 4y equals 13 stays the same. So the only part I changed was x. And then I just solve for y. I need to do my multiplication. Negative 5 times negative 5 is a positive 25 minus 4y equals 13. To solve for y, I need to cancel that 25. To cancel out a positive 25, I will subtract 25 because 25 minus 25 is 0. So these are gone. My negative 4y just comes down. 13 minus 25, I will subtract those because the signs are different. I get 12, but it will be a negative 12 because you keep the sign of the bigger number. And then from there, I just divide both sides by negative 4. So here and here. The negative 4's cancel. I get y equals negative 12 divided by negative 4 is positive 3. So my solution is negative 5, comma 3. Remember, always put the x term first and then the y. For problem number 2, our equations are negative 3x plus 2y equals 27 and negative 8x minus 9y equals 29. So again, just looking at these, nothing's going to cancel. All right, neither one has numbers that are the same, so I know I have to multiply both equations, just like we did for problem number 1. So taking a look at this, 3 and 8, we need a common denominator. Remember, count up the multiples of the larger number, okay? So 3 cannot become 8, so we do 8 times 2 is 16. 3 cannot become 16. 8 times 3 is 24. 3 can become 24. So 24 would be the number that 8 and 3 could both become. Let's check out the y's, 2 and 9. All right, 2 cannot become 9, so if I take 9 times 2, I would get 18. 2 can become 18, so 18 would be the common number for the y's. So between 24 and 18, I would pick the 18 because it's smaller. So we're going to go with the 18. Now, what we need to do is figure out what to multiply each one of these y terms by so that they are 18. So I have to think, what number times 2 would give me 18? That number would be 9. And what number times 9 would give me 18? That would be 2. Now I need to determine if one of them needs to be negative. So looking at our signs, this one is a positive 2, this one's a negative 9. If I leave my numbers the way they are right now, 9 times 2 is positive 18. 2 times negative 9 is negative 18. The signs would be different. So that means I don't need to multiply by a negative in this case. So don't change either of these. Leave them both as positive. The signs are already different, so you don't have to change the signs. So I'm going to multiply this first equation by positive 9. Now if you need to, go ahead and use a calculator for this. Some of the numbers get a little big. 9 times negative 3x is negative 27x. 9 times 2y is positive 18y equals 9 times 27, and I did this earlier, is 243. For the second equation, multiply everything by that 2. Remember, you have to multiply all 3 terms. So 2 times negative 8x is negative 16x. 2 times negative 9y is negative 18y. And 2 times 29 is 58. So now I have a positive 18, I have a negative 18. Those are going to cancel. So I can go ahead and add my 2 equations together. So negative 27x plus negative 16x would give me negative 43x. My 18y's would cancel, so I equals 243 plus 58. Well, 3 plus 8 is 11. 5 plus 4 is 9, plus 1 is 10. Carry the 1. 2 plus 1 is 3. So we get 301. So from here, all I need to do is divide both sides by negative 43. So again, if you need to use a calculator, that is fine. 301 divided by negative 43 is negative 7. So x is negative 7 for this problem. But I still need to find y. So to find y, again, I would go back to one of the original equations because those are always going to be smaller than these ones because we multiplied these ones. I definitely don't want to use 243. So I would use the first equation, 3, 2, and 27. Those are the smallest numbers we have. So that's the one I'm going to pick. What I need to do is take out the x, and I'm going to put negative 7 in its place. Remember, always put it in for the letter it's equal to. So I'm going to have negative 3, but instead of x, I'm going to put negative 7 plus 2y equals 27. So now I just solve for y. So to solve this for y, I need to go ahead and do my multiplication. Negative 3 times negative 7 is a positive 21 plus 2y equals 27. From there, I need to cancel out that positive 21, so I'm going to subtract 21. So I subtract 21 on both sides. 21 minus 21 is 0, so they cancel. My 2y just comes down. And 27 minus 21 is 6. So I'm almost finished. I have one more step. I need to divide both sides by 2. So when I divide by 2, 6 divided by 2 is positive 3. So my solution, always put that x term first. Our solution is negative 7, 3 for problem number 2. for problem number 3, our equations are negative 2x plus 4y equals 14 and negative 3x plus 10y equals 17. Looking at this, I already know I can't just cancel anything out right away because the numbers are not the same for either letter. So what I need to do is figure out which letter is going to be easiest to cancel out, easiest to work with. So I'm going to start with the x's. I have 2 and 3. Look at the bigger number. There's nothing I can multiply 2 by to make it 3, no whole number anyway. So that means I need to think, okay, 3 times 2 is 6. I can make 2 become 6. Okay, there's something I can multiply 2 by to make it 6. So 6 is my common number here. All right, for 4 and 10, all right, 10 would be my bigger number. There's nothing I can multiply 4 by to make it 10. So then I think 10 times 2 is 20. I can multiply 4 by 5 to make it 20. So 20 would be my common number for the y's. Now 6 is obviously smaller than the 20, so I'm going to go with the 6. Cancel out that 20. All right, so what I need to do now is look at my x terms and think, what do I multiply negative 2x by to make it 6? Well, I would have to multiply that by 3. 3 times 2 would give me 6. And then I have to think, okay, what times 3 would give me 6? The answer is 2. 2 times 3 is 6. Now I need to check my signs. 3 times negative 2x is a negative 6x. 2 times negative 3x is negative 6x. So in both of these cases, I'm going to get a negative 6x. And if they're both negative, they won't cancel out. I need the signs to be different. So what I'm going to do is make one of these negative. Negative 3 times negative 2 is positive 6x. That would actually make it so that they would cancel. Only make one of them negative. Don't make them both negative or it won't help anything. All right, so what I'm going to do is multiply this first equation by negative 3. Negative 3 times negative 2x is positive 6x. Negative 3 times 4y is negative 12y. And negative 3 times 14 is negative 42. Now I multiply the second equation by positive 2. Make sure you multiply all 3 terms, okay? 2 times negative 3x is negative 6x. 2 times 10y is a positive 20y equals 2 times 17 is 34. Yep. Now I can add the 2 equations together because my x's will cancel out. A positive 6x and a negative 6x is 0, so those are gone. Negative 12y plus 20 is 8y. The signs were different, that's why I subtracted. Make sure you keep the sign of that bigger number. Negative 42 plus 34. Signs are different, so again I will subtract. I will get 8, but this time it will be negative 8, because again, keep the sign of that bigger number. And then I just divide both sides by 8. So 8's cancel out. I get y equals negative 8 divided by 8 is negative 1. Halfway done, but I still need my x term. So again, remember those first 2 equations are always going to have the smaller numbers. These last 2 equations, we multiply them and they're going to be bigger than the first, always. So I go back to the originals. Now of the 2 originals, I'm going to use the first one because again, the numbers are smaller. I like to use the smaller numbers. This time though, I'm going to plug my negative 1 in for y, because that's what y is equal to. So make sure you plug it in for the right letter or you're going to get the wrong answer. So I'm going to have negative 2x, that stays the same. So does my plus 4. But instead of y, I'm going to put negative 1 in its place. Equals 14. So now I solve this equation for y. The first step is to do the multiplication. 4 times negative 1. So my negative 2x stays the same. 4 times negative 1 is negative 4, and then equals 14 just comes down. After this, I need to cancel out the minus 4. So to cancel it, I must do the opposite. The opposite would be plus 4 on both sides. Minus 4 and plus 4 cancel. Those are gone. I get negative 2x equals 14 plus 4 is 18. So I bring this down as 18. And then my last step here is to do the division. All right, so I need to divide both sides by my negative 2, here and here. So my negative 2's cancel. I get x equals 18 divided by negative 2 is negative 9. So the x coordinate is negative 9. So to write my solution, remember, you always write that x coordinate first, alphabetical, x before y. So x is negative 9, that comes first, comma, and then the y, which is negative 1. So our solution for number 3 is negative 9, comma, negative 1. At this time, go ahead and pause the video, work on problem number 4 on your own, and then once you're finished, come back and check your work with mine. For problem number 4, our two equations were negative 4x plus 3y equals negative 11, and negative 9x plus 7y equals negative 23. So I took a look at our letters. I found that 4 and 9, their common number was 36. And then for 3 and 7, their common number was 21. So I went with the y's, the 3 and the 7, because the number was smaller. So I multiplied the first equation by negative 7 and the second equation by positive 3. Now I made the 7 negative because these had the same signs. I don't want the signs to be the same, I want the signs to be different. So to change one of the signs, I made the 7 negative. I kept the 3 positive, that way the first equation would have a negative 21y, the second equation would have a positive 21y. So I multiplied them both. I got 28x minus 21y equals 77, and negative 27x plus 21y equals negative 69. So I added the two equations together. My 21y's canceled. 28x and negative 27x, the signs were different, so I actually subtracted those. 28 minus 27 is 1x. And remember, 1x is the same thing as just x, so I left that just x. 77 and negative 69, the signs are different, so I subtracted those as well. 77 minus 69 is 8, and I kept the sign of the larger number, so this is a positive 8. So I found that x is equal to 8. From there, I picked one of the original problems, and I actually picked the first one because the numbers were smaller. And what I did was I replaced x with 8. So I have negative 4, but instead of x, I put 8, plus 3y equals negative 11. I did my multiplication, I got negative 32, and then to cancel out the negative 32, I added 32 to both sides. So those canceled, they were gone. I have 3y equals. Here the signs were different, so I subtracted the 2, 32 minus 11. That gave me 21, and I kept the sign of the bigger number, so it's positive 21. And then from there, I just divided both sides by 3. So y equals 21 divided by 7, 21 divided by 3 is 7. So my answer was 8, 7. I made sure I put the x term first and then the y. And that's your solution for number 4 and the end of our lesson on systems of equations using elimination. And this was our 3rd lesson.